Okay, before the break, we looked at stepped outside of what we have been studying for the most part this course and looked at PowerShell. I always like to do that in this class because if you're heading down an IT pathway, that will be one of the most useful languages for you to know. So I like to get an early start, and when we finish the next lecture section, that's going to be my recommendation for lab time today, is to play around with some of that PowerShell stuff and start getting used to that. We have one more that I always like to include as far as the really useful scripting, the things that will be most useful to everybody, that we'll probably do the first day of module 8 is where it currently stands on the plan. But those things, and then as time allows, I have a list of lots and lots of things that I think will be very useful for you all, and try to squeeze in as many as we can on top of our core objectives. There's one more thing, kind of a continuation from what we did the other day, that is an important one to talk about. So we were talking about arrays. I'll put that on the label, so it's more about arrays. But in particular, this time, we're going to look at multi-dimensional arrays. Multi-dimensional arrays is a very important concept, and after we draw some pictures up here on the board, you'll see why it's important. So we talked about arrays, saw that the other day, where we're working with an entire collection of data instead of a bunch of individual data points. Has some advantages. They're kind of hard to see at the introduction level, but as you progress further, you'll come across more and more advantages of those. Systematically organized memory locations, whether an array by definition, which is non-dynamic. If we need to store more elements, we have to basically make a new bigger array, copy everything over, and then start adding some more stuff in them. They're non-dynamic. So we also looked at list, but we do use the word array as our generic term when we're talking about it. So we store a bunch of things. We put integers in there, characters, strings, booleans. We put pictures in there. Any data type we have, we can store in an array. But what about other arrays? It's kind of like a data type. We store an array inside of an array. Hopefully you're already anticipating the answer to that is yes. So I'm just going to do this in the form of a picture. Our definition on anything hasn't changed. So once again, with our stack heap diagrams, which again are other types of collections that we can work with. And in general, when we work with large collections of data, they're very similar. They have different advantages. Stacks have a very predefined order. Stacks are very natural to the machine. We briefly saw a stack when we looked at recursion. The machine just naturally stacks things up and then works back down that stack. And the same way we put stuff in there. A heap's a special kind of tree that no matter how big it is, it doesn't change over retrieval time. Doesn't matter if we have 3 data points or 3 trillion data points in that heap. It would take the same amount of time to retrieve any of them. So it's a little more complicated. That one doesn't show up a much later classes for those going that way, but still collections of data. And we use those for representing things. So if we have an array, which we saw the other day, is sort of a reference to a spot in memory where we can store a bunch of elements. I'll put 3, and then I'll put some little dashes like this to indicate it's not 3 bits. That's 3 data types. Each one of them, 3 pieces of data. Each one of them is made up of a bunch of bits itself. The other day, where we had our data directly in there, and we refer to it as like index 0, index 1, index 2, or whichever indexes we are, because some languages start at 1, some start at 0, so you have to know which language you're in. But instead of putting our data directly there, like we did the other day, I'm going to erase those little marks to represent the bits. What if we did this again and just the thing in our array was actually another array? I better make this arrow come all the way down. Otherwise that picture is going to be messy. And then down here, that first element here is an array of 3 items, and our data is down here. The same thing here. This element in the array is actually a reference to another array. Maybe we'll put 4 elements in this one, and then those some little tick marks to represent all the bits for each data point. So then instead of an array, let's put 2 in this one. We have an array, a collection of other collections. So that's the multi-dimensional part. Our basic array is sort of one-dimensional. We just put our data in a big collection. Then a second dimension of that, and then that pattern can continue indefinitely. Each one of these could continue in another one. So that's the actual picture, but that's not how we think about it. The way we would think about it, I'm going to add ish because this is an introduction. So there's some fine details to be worked in well past in a class that has an introduction in the label or starts with the number 1. This is what's actually going on, but what we're thinking about when we do this, a lot of people think about this a little bit different. So I'll draw an alternative heap over here. So an alternative heap, show the way we would think about it, is basically most people, when we think about it, if we turn this one sideways, we get what we think of as a table. So our multi-dimensional array reference name, the thing we're going to ask for in our code, points to an array that's filled with other arrays. Well, I'll just draw it square because, and that's the big advantage here. A two-dimensional array, we can think of that as a table. We have things set up in rows and columns. So when we organize our data, this is the format that makes a lot more sense to most people when thinking about it. Kind of like we would put it on a spreadsheet. We have all those nice rows and columns so we can organize things in some sort of like maybe categories going down, or yeah, a bunch of categories, similar categories going down the columns. And each row is a particular piece of data that is represented by all those different pieces that we split into the categories of the columns. And normally when we draw the stack heap diagram, we draw it this way because this sort of diagram is to help us visualize what's going on and make sense of it. So it just makes more sense to draw it the way we think of it. I just wanted to make sure and draw the actual picture up there. So technically called a two-dimensional array, but we're just going to say table when we talk about those. And for a three-dimensional array, again, we could just put another array in each one of those, and then we could picture things of, we could still kind of visualize it as like stacks coming out of the table, or, you know, like an actual table laying flat, and then we stack stuff up on the table. beyond three-dimensional arrays, it's kind of hard to visualize, but our pattern of putting arrays inside of arrays can continue indefinitely, at least till the computer runs out of room. For our class here, we'll be using two-dimensional arrays, and even as you continue further and further into whatever path you're on, yes, it's very. So the question popped up in the chat room about, is it like a relational database? So yes, a relational database is a two-dimensional array, and then the thing with the relational databases is the relationships. So let me draw a couple tables over here. So our things are organized into different columns. I'm just going to write like 1, 2, 3, 4 for a simplified picture here. And then we might have another table that holds different data to organize it. But they might have something in common, like maybe this one also has that 3, has different things on all the other columns. So these two columns have a relationship of a foreign key, some unique identifier in one of the tables that is referenced in the other table, but it creates a relationship between them. So then when we go to work with our data and sort through it, we don't have to read in all of the data. If we needed a particular thing, like on a text file, if our data was stored in a text file, we'd have to read that entire file, look through it, find the piece of data we want, and then kind of discard the rest from RAM so that we have that RAM available to do stuff with. But with a relational database, we can use that relationship. So if we say, maybe we know this piece of data right here, we can follow relationships around because of our row. This piece of data is related to this piece of data, which is in that column, which would be a foreign key to the other table. So we can follow that relationship around, maybe over here, and grab this piece of data, just using the relationships, and we can ignore every other bit of data in those tables. So it allows us to jump from spot to spot. But the entire relational database is set up in multidimensional arrays. By definition, the definition of arrays, right? For those who have worked with relational databases, we have to say what type of data goes in each one of our cells, or each one of our columns, very explicitly. Sometimes even explicit about how many bytes we have available there. So fixed size, and we can't change the size easily. I mean, it takes quite a bit of SQL to do some edits to change the size of the table. So it's a non-dynamic structure. So the entire relational database is a two-dimensional array or a table. So definitely the one we work with the most often is 2 dimensions, but we can continue it on. Did that answer your question, Ethan? I felt like I kind of got on a little sidetrack there.
Oh yeah, definitely. That's helpful. Thank you.
Yeah, it cuts down we only need those 2 pieces of data and the relationships between them. And we can ignore the rest of the database, save a space. So one thing I guess would be the indexing. And that's another one, we have to know the language we're working in. So I'm going to use the same reference. So ARR, that's our typical throwaway reference name for an ARR array in generic examples. We saw the other day we put our index in there, so maybe number 1. And then for the second one, there's 2 very common ways that we would refer to those. In some languages, we put the second array afterwards, so I'll put like a 3 there just for an example. But really, when we start looking through those, both of our indexes are probably going to be probably going to be variables so that we're able to check everything in the array. Right, from that backpack analogy that last week, we have to dig all the way through the backpack, and then maybe the arrays inside of there would be like the folders in the backpack. It's like, oh, the notes I'm looking for is not here, so I have to dig through the backpack and check the folders inside of the backpack. The other type of notation kind of gets rid of those extra middle symbols, and uses a comma, so it'd be like 1,3. Those are the two we see most often for multi-dimensional arrays. We'll use both of them in here. So Python does it this way, and Raptor, which is based off Perl, does it this way. So we'll see both of the common notations here. But again, it's one of those things you have to know the language you're working in. And all right, I remember on the board, but yeah, the last thing in the notes is just like we needed a loop to go through an array we saw the other day. But if we need a multi-dimensional, if we have a multi-dimensional array, we have to start nesting our loops in order to go all the way through it. So we have an outer loop that would walk through our first index. And inside of that, we have an inner loop that goes through our other index, so that as we go through this picture, so our outer loop goes through this first one. And as we do that, we need to loop through everything in that row. Then we go to the next row, loop through everything in that row, go to the next row, and loop through everything in that row. So we need loops inside of loops in order to walk through multi-dimensional arrays, which 90% of the ones you use, probably more than 90% of the ones you use are going to be two-dimensional arrays where it's like a table. Does anybody have any questions? Do a quick example of this. Okay, I assume the silence means no questions, so let's do a quick example. I'll just do the flow chart again. The big difference, logically it'll be the same. The big difference is the Python uses the two sets of square brackets, and Raptor's going to use the lower notation where we get rid of that redundant middle part, because we're still talking about arrays, so we don't need a whole bunch of extra brackets in there where a typo could happen, is the thought behind cutting all those out of there. So again, it's going to be a lot of work, a lot of stuff to fill up an array. So I'll just add a subchart to do that. Fill array. A payroll example, that'll work. That sounds good. Employee example. So employee data example for 2D arrays. So we'll go to fill things up. So we'll set our employees array index 1, 1. Now we have two indexes. Maybe we'll make that the name. So this is an alternative to the parallel arrays, right? The other day we put two arrays where we would line up our indexes so that like index 1 means the same thing in both of them. But here, instead of the two separate arrays, we'll go ahead and stick one of the arrays into the other one so that we have end up with effectively a big table. Then we'll need a whole bunch of things. We'll set employees row 1, column 2 to I guess it's ready to pay. 1987 sounds like a good amount of decent salary. And maybe an address just to have something. So employees row 1, column 3 can be the town he lives in, maybe Sellersburg. And I am completely making this up. There's not a real Bob that this refers to. And I'll copy that and paste it in to make a second employee. So row 2, so now our outer index, our first index is, which represents the rows in the table, will be the next employee. So maybe a Sally. And row 2, index 2 be Sally's rate of pay. So I don't know, 24.56. Oh, I got save. And row 2, column 3, maybe she lives in Sellersburg as well. I'll make the copy and paste easier. Maybe one more. Paste this. Row 3, column 1. I'll make an employee called Mary. Row 3, column 2. 1978. I think that's the same thing as what. Oh, close to the same thing as what he made. Then row 3, column 3. Maybe she lives in a different town. So you can see that programming thing that would be missing when we think about spreadsheets and those nice rows and columns that we do have to kind of manually set up every single one. But once we get that filled, then we can kind of use it the same way. So I'll call it clear console to keep junk out of the way, and then I'll call that fill array. Oh, whoops, I made a typo somewhere. So you can see over in our
the employees.
Yeah, somebody's the L disappeared. Oh, that one right there. Let's see if that worked. Oh yeah, because that's copy and pasted, isn't it? So it's usually a good idea to check for typos before copying and pasting. And make sure that first line runs and then copy and paste that, so that you don't copy and paste the error everywhere like I just did. There we go. Now we only have one array, and we can see over in the watch window, it has that expansion thing again. So we expand it. There's 3 rows, and then each row contains 3 columns in it. So if we wanted to walk through that, we would need nested loops, which means we'll actually need 2 indexes. So one for the outer array. So set I equal to 1, is Raptor is going to start counting at 1 instead of 0. Then what we saw the other day, do this every time for a loop. I as he starts at 1, we'll go until I is greater than the length of our employees array. And each time through, we need to make sure and increment that index. So set I equal to I plus 1, which I found, I think I spelled out index last week. I found it interesting when I was looking at the homework, the number of people that went ahead and used I. I can always tell who's had some programming before, because it's fairly standard to use I for index. And then we follow that with J and K. Usually J, because we're dealing with two-dimensional arrays more than any other. But I for index, and we'll always do this. Start at 1, go through our loop until we pass the end of it, which in our flowcharts here, we leave when that condition is true. So we're going to go until we're bigger than the length of the array, which actually I think we want to go bigger or equal to. I'll adjust that in a moment. I think we need to go bigger or equal to in this case, and then increment our index. And last time we would just do something in this little section right here. But what we need to do is our first index is the row. So what we have to do is walk through all our columns. So we do the same thing again. We'll set an index. Typically, J is used for I for index and J for the letter after I in the alphabet. They kind of go together. Easy things to use for an index. We'll go until J is greater than length of, what's our employees array again? But it's kind of an issue here, right? They shouldn't both have the same condition. That's because our inner one needs to refer to the outer index. Whoops, not 1, to the ith index. So our outer one refers to the overall array, and then our inner one refers to the first index. And then before we finish the loop, we need to make sure and remember to increment J so that we will eventually leave that loop. J is what already was in that variable plus 1 more. So again, that situation where the variable is referred to on both sides of the assignment, sort of a reassignment. For us, I'll just print that out. Employees I, comma J. Don't end the current line. So I'll print them out as J increments. I'll print that first one, and then I'll put maybe a couple spaces and a pipe symbol, and a couple more spaces to kind of try and make it look like a table. And we'll do that each time through. And then afterwards, when we get all the way to the end of the row, and before we come out and do the next row, we want to print a line break. So I'll just put an empty string, quote marks with nothing in between them, but there is a line break this time. Oh, and uncheck the line break box. That way all the stuff prints in one solid row. Let's see if I made an error there. So it runs through. Uh-oh, where did it crash at? So that filled up. I guess it crashed when it hit here. I'm just going to use the numbers. Keep our example short. We know how many things there are here in our case, but we do still have that. We have 3 of both of them. There's 3 columns in each row, and then 3 rows. So I'm just going to use that number. We do have the other one, but I wanted to keep this example kind of short and basic so y'all can just see the core parts of the tool. Oh. There we go. And yeah, so there's an array going down, but that array is filled with other arrays. So a collection of collections of data, which gives us tables to work with, which most people seem to find fairly intuitive, right? It's a nice way to organize our data. It helps us visualize and keep track of it. And the key thing is once we get it filled up, then we just need nested loops to walk through it. Might as well do one in Python as well. Save that. I'll do it locally in Python. Yeah, I'll use idle. I'll use spider. This one that is getting ready to open. This is my favorite IDE to work with and to work with Python in. That's integrated development environment, which basically means a text editor, place to write our code, and a button to run it. Usually a run button as well, but a place to write our code. This is my favorite one to work with Python in because most IDEs, Python was an afterthought. It was just a plugin they added to IDEs that were probably meant to work with something in the C family of language. This one was intended solely for working with Python. So it has some advantages to that being just an afterthought tacked on to a fancy place to write code. This one was even made entirely in Python. There's no other language in use but Python in this entire process here. So a good place to write code. It's Spider IDE. Make sure you put IDE if you go search, if you want to give that a try. Because Spider's
I'm
like
grabbing it right now.
Spider gets you some athletic wear. So make sure you look for Spider IDE. Some people at MIT put this together specifically for their studies in machine learning things because they didn't want to use a notebook. They wanted to use traditional scripting for machine learning. So they built their own thing. So it's actually optimized for that if you're interested in machine learning. So this we would do kind of the same way. So I'll make an employees array. I'll do the same thing. We saw before that when we have a one-dimensional array, we can put our values in there as comma separated list, right? Well, it's just same thing, but it just so happens that our list needs to be another array. So like Bob makes 1789 and lives in Sellersburg, I think. Then a comma. So notice, let me add a space here. I'll add an extra space at the beginning to make that stand out. So the thing inside of our square brackets that we add in there is another list itself. Sally makes 2567, lives in Sellersburg. I think that's what I did the first time. And then, oops, it's quote marks on that. So Mary makes about the same as Bob, so 1793, and lives in, I can't remember where I put the first time. Lives in New Albany. So very similar setup where we can put comma separated lists inside of square brackets. It's just that the things in our comma separated list is another comma separated list in square brackets. So we can actually see the arrays inside of an array storing arrays. And then we need to walk through it in a loop. Did the textbook use for loops? Anybody see for loops in our textbook?
I couldn't tell you.
Okay, so there is a special kind of loop. A lot of intro Python books want to use for loops incorrectly, because in Python we don't actually have a for loop. We have what's called a for each loop.
Yeah, we were talking about for loops. We did do for loops. I was thinking of the number 4. Brain fart. Yeah.
So Python doesn't
we did for
actually have for loops. It's what is called for each loops.
Yes.
So
different.
We should not have numbers. Having numbers in a for loop is a very new thing to Python. And they probably showed that in the introduction level. So we could say like for E in employees. So for this thing in our collection, and it will just go through them one at a time. So if I just print that out, print out E, notice there's no number to index it or anything. I probably should have 2D arrays.py. So notice there's no number used to index it. I kind of alluded to this earlier, is why I wanted to say this. If I run that, you see it splits it up automatically. And then we can put another loop inside of there. So like for I in E, print I. So I alluded to this earlier. The computer can count. We don't have to do the counting ourselves. We don't have to worry about the numbers. It looked more like a table the way we did it the first time. I just wanted to briefly show that. I'm going to comment that out and do something like what we just did. So I'll set I equal to 1. And while I is less than 3, we'll set that J variable and then do while J is less than 3. And then print each one. Print employees I, J, plus a pipe symbol, plus employees I, J. Oh wait, that's going to be the same thing. Let me do this. I'll start each row off as an empty string, and then I'll take whatever was there plus that next thing plus a pipe symbol. So that should look very similar to what we were outputting, only with sort of that increment operation. So we'll add the next thing to this string. And then when we get all the way to the end of that, then we'll print that out. So a slight change from the other one. Equals J plus 1. So we don't want an infinite loop, and I equals I plus 1. So those key parts again, we set up our variable, we loop until the length of our array, and right before we end, we'll increment our counter. Then we set up our index, loop through and do stuff. And what we're doing is we created an empty string, and then on each pass through there, we'll add something to it, to that string, then increment our variable. And when we finish all of the inner looping stuff, then we'll print that row out. There's an error here. Somebody want to tell me what the error is? I know you all have experienced it a time or two by now.
Yeah, but I guess I experienced a typo one time.
Do you see anything wrong with that code that I wrote? Anybody? Oh, we'll look at the error message. I'll highlight though, what happens when we try to add that to a string?
Yeah,
Because-
just
Oh,
never
You
happens.
need to add float.
So, oh, well, the other way.
It needs a string and then like
We need
and
to
then
turn
you
it into a string because we can't add a floating point
Concatenate
number
it.
to a string.
yeah, you can't add float to, just
Okay.
nothing. So
Yeah.
you got to have a string, right?
Yes. And then our other part, turning a string into a string is no problem whatsoever. So we can just do that every time, and that it won't hurt at all to give that. computer an
But what's
extra
different
step.
is you can't turn a float into a string. So it's just like,
Yeah, we can't concatenate this one.
yep.
Oh, I started the indexes at the wrong one. I still had the previous one on mine. Again, our arrays start at
Should have
0,
had 0.
not 1.
Okay, yeah.
Yep. But
So there's 2 trick questions there.
yes, I like to throw errors in class instead of just typing it up directly and be like, okay, remember to do it in exactly this order. It's much more useful to look at the error and see how to fix that and what those messages
It
mean.
sticks in the brain better. It really does.
Yes. There we go. So we get the same table. So you see the same logic applies. There's a shortcut that I alluded to earlier, so I thought I would go ahead and include here. But we fill up our array, which at the introduction level seems like more work. It doesn't seem like we're really saving anything over using variables, but it does pay off in the long run. Especially when we get into things like this. And some of the people who have programmed before, I've already seen things like comprehension show up and things that are definitely beyond the level of this course, which I'm always glad to see. More is always acceptable in my class. The instructions are like the baseline level. If you want to do more, have at it, as long as you meet the basic requirements. But our logic is the same whether we do it here or in Python or 327. So, or if we saw another one too. If we go to PowerShell ISE, our array here looked a little bit different because well, I guess I could do it this way. Yeah, I'll do it this way. I'll actually spell them out. So like, our array list, we have to do something special. We have to call for this special one, system.collections.arraylist, which you saw was at the top of the prediction list, even though that's not alphabetical order. That's just a common thing to do. Call it employees. So we need a $, equals at some stuff in parentheses. And then each one of those things in parentheses is again going to be an array. So like Bob makes $19.90 per hour and lives in Sellersburg. Close that parenthesis. Whoops. A lot of our text editors, if there's an obvious closing parenthesis and we hit the parenthesis button, it won't add another one in. But apparently this text editor doesn't. Then the next one again is an at array. So an array, and we have Sally, who makes a bit more, so like $27.77, and Sally lived in Sellersburg, I think. Then our last one, again, we'll put an array inside of there, which we create an array with at and then some parentheses. And then inside it's kind of what we're doing with the square brackets in Python. So hopefully y'all are seeing some similarities there. What was the third one? Mary makes a 1987, because we need that as a number so we can do math with it. And maybe she lives in New Albany. I think that's what I put there. Oh, too many closing parentheses. So there's our array, and then we can loop through it the same way. So I starts at 0, while I is, don't forget your dollar signs in PowerShell, while I is less than, oh, the length of the array, we didn't see that earlier. You use the thing, or y'all know how to Google stuff. Length of array in PowerShell. Dot length. So I wanted to point at that because that's going to be my recommendation. It's less than employees dot length. Oh. Length of array in PowerShell. Oh, is it different here? It's probably count. Count is the number of elements that are in the array list. So I need a dot count. So there's a lot of that when we're learning the new syntax. We've seen the logics, we just need the syntax for the other one. And Google knows the syntax of every language. So if I start typing count, employees.count, then each time through we'll set a variable j to start at 0 again. And I'll do it the same way we just did in Python. I'll make something called row, starts as an empty string. And while j is less than our employees, the outer index dot count, or well, we know it's 3. I'm just going to do the 3 here because everything you'll need to do for this class, you will know the number of, and that nesting the count thing gets a little complicated. That's why I'm just switching to the numbers. Everything we do in this class, we will know how big our table is. So while we're less than 3, then that row variable, which notice it. I was mixing my Python syntax in there. Need parentheses. That'll make some of those little red lines go away. So here, unlike Python, we don't have to indent it, but the indenting helps to read it. So row is going to be whatever was in row, and concatenate on the employees array. Row I, column J. Going that way? Nope. Oh. And another thing is, the more languages you learn, the more they start to run together, little typos come easier and easier. That should look very familiar. Then we can, whoops, how did my cursor get down there? Then we can increment that J variable. Come back out, write whatever that is stored in that row variable at this point. I'm going to indent that again. So the indenting is not necessary here. It just makes it a little easier to keep track of what goes where. So it's only for your benefit. Then after we write that, we'll increment what's in the I variable. Close off that last curly brace. And I think that was everything. That's right. Oh, something's going very wrong.
It's looping.
Yeah, definitely looping. Let's see. So I starts at 0 while I is less than 3. I is assigned I plus 1.
Oh, okay.
So that's why we have to do debug. Go through it one line at a time and act like you're the computer. Right. So we start here. That line looks good. Loop through this, increment it, and then yeah, just kind of go through the line, go through things one line at a time. There we go. Oh, could probably make that look a little bit better. So that plus a space and a pipe symbol. There we go. There we go. So same output. See how we have that same logic everywhere. To be array dot ps1, and ps1 is a PowerShell script, just like .py is a Python script, but the same logic applies, just a different syntax. And the reason I showed this PowerShell one is because that is, in the long run, I think that is one that everybody is going to need to use at some point. So where's chat room? Let me put those in the chat room. So add a file. Here's the Raptor one. Add a file. Here's the Python one. Add a file. Not save it. I must have saved it in the wrong spot. Let me try that again. Save as, oh, in the delete folder, then call it that. There it is. And there's the PowerShell one. So if you want to download those 3 examples, the main thing is notice that our logic's the same everywhere. Whether we're in the, whoops, the operating system control language. What did I do?
Running sources disabled.
I have to change. I'm in the wrong spot
Oh, okay.
because this, I just stored this in the delete folder, but it's saved over in the users folder. So set location to document. What? Oh, set location. Whoops. To documents / delete. There we go. Now I should be able to run it. Nope. I don't know why that's not letting me run it. I'll do this.
Maybe as administrator or something, you got stuff locked down.
Yeah, if I make it an unnamed script, if it's not a saved script, it'll go ahead and run it. Yeah, that's just a permission thing.
I thought so.
It can't run things by default. It's a security risk. It doesn't know who wrote that script, even though it was written on this computer. So at least for now, copy and paste to a blank file will work. Just a permissions thing, but that's going to be on the scope of our course. So you can see the logic there is the same as the logic in Python. Set up our array and loop through it and spit out the output to kind of look like a table, or in the flowchart. Set up the array, then loop through it and spit out the output. So however we choose to implement that script is the same everywhere. I showed PowerShell today because that will be beneficial to all of y'all. That's your, every time you click one of the GUI, one of the icons on your machine, that on a Windows machine, that is actually running a PowerShell script in the background. So it's good to, that's a really, really useful scripting language to know. For server administrators, networking people, cybersecurity, you'll be working there a lot. Software developers, you'll also need to work there because one thing that can be dangerous is just giving your user a program to run. Right? If our program depends on external files or something, can we really trust our users not to delete those files because they don't know what they are, which would make our program suddenly crash? So usually instead of letting the end user start a script directly, we put together like a PowerShell script or a batch file or a shell script of some sorts.
Yeah, we put quiet.
Make sure everything, all the files and pictures and everything that's needed to run the program is there. And then that script starts the program. That way the user doesn't break it. So it's something that will be useful for everybody. So that's my recommendation for lab time. Hopefully the two-dimensional arrays make sense. Most people find that quite natural. That's the one that will be in your homework. So if you think you might need some more practice with that, obviously you can work on whatever you want, but my recommendation would be that kind of get started in that PowerShell stuff. It will be useful for everybody. But please use our time productively, and I can answer questions to more classes than just this one. And until 4:50, that's what I'm going to be doing here. I'll be sitting here ready to answer any questions. Ivy Line messages and text messages are two things that make noise on my phone. And from now to 4:50, I'll be able to jump back on the Zoom call in a split second to address questions. Does anybody have any questions before we wrap up for today?
No further questions.
Not for me, no.
Okay, I assume the silence from everybody else means no questions. So y'all have a great afternoon. If you have any, let me know.
Okay.
Please use our time productively, and I will see you on Wednesday. Oh, and on Wednesday, we're going to get into some file stuff that's not necessarily for the homework. It's what we're needing in the long run. It's another one that
Okay.
we're going to take it a step further than is needed for the homework to see what you all are going to need to get out of Python. Something more useful than our textbook has you do in Python for as far as everybody's goals. So I'll see you Wednesday and we'll go over that.
Bye.
Have a good one.